So now we have to find the convolution between the input and the input and the step, right? So whenever we have already seen that what happens if you are convolving any input with it of the impulse. Now we are talking about the step. So I can apply the mathematical formula of convolution. The mathematical formula of convolution says that x of n convolved with u of n is going to be summation k is equal to minus infinity to infinity x of k u of n minus k. X of k u of n minus k. Can you please tell me what is the independent variable here? Is it k or is it n? What is the independent variable inside? Very good. So k is going to be the independent variable for us. So can you please tell me what is the value of u of n minus k? What is the value of u of n minus k? If we take the k as an independent variable, then u of k is equal to 1 for k greater than or equal to 0, and it is equal to 0 for k less than 0. U of k is equal to 1 for k greater than or equal to 0, and it is equal to 0 for k less than 0. If I talk about u of n minus k, if I talk about u of n minus k, just replace k with n minus k. It will be equal to 1 for k, which is n minus k, greater than or equal to 0, and it is equal to 0 for n minus k less than 0. Implies that u of n minus k will be equal to 1 for the value of k which is less than or equal to n. For the value of k which is less than or equal to n, and it is equal to 0 for the value of k greater than n. U of n minus k will be equal to 1 for the value of k less than or equal to n, and it is equal to 0 for k greater than n. Okay, so we are just using the concept of unit step that we have learned in the first chapter, and because we know k is an independent variable, so we are writing for k, then we are replacing k with of n minus k. We are just replacing k with n minus k, and we are seeing u of n minus k where it is 1 and where it is 0. So we have learned that u of n minus k is 1 for k less than or equal to n. So now I will be breaking this particular summation into two parts, from k is equal to minus infinity to n, and the other is from k is equal to n plus 1 to infinity. X of k u of n minus k, and here also x of k u of n minus k. So between minus infinity to n, what is the value of u of n minus k? Between minus infinity to n, what is the value of u of n minus k? Between n plus 1 to infinity, the value is 0. Because for k less than or equal to n, for any value of k which is less than or equal to n, u of n minus k is 1, and here it is 0. So therefore, x of n convolved with u of n, x of n convolved with u of n is going to be equal to summation k is equal to minus infinity to n x of k. K is equal to minus infinity to n x of k. This is an important result. So I can also generalize it for the continuous time. I can also generalize it for continuous time. U of t convolved with x of t convolved with u of t. In the place of integration, what you'll have? In the place of integration, you'll be having summation. In the place of summation, you'll be having integration. In the place of k, we can write tau. In the place of k, we can write tau. Tau is equal to minus infinity. In the place of n, we can write t. And here we can write x of tau d tau. X of tau d tau. Now, can you please tell me what is this operation called as? Integral minus infinity to t x of tau d tau. What is this operation called as? This is what we call as the integration of the signal. This is what we call as an integration of a signal. Integrator, yes. So whenever we convolve any signal with a impulse, whenever we convolve any signal with an impulse, we are getting the signal itself. Whenever we convolve a signal with a step, what are we going to get? Whenever we convolve an impulse with a step, then the signal will be integrated. Or in a simple way, so here you can see that the h of t is nothing but u of t. H of t is nothing but u of t. So if you consider a system where if you are giving an impulse as an input, the impulse response you are getting is u of t. It means if you are applying the input as impulse, the unit impulse, you are getting the output as unit step. Now what is the system doing here? If you are applying del of t, you are getting u of t. What is the system doing here? The system is just integrating your input. So if I am applying any input for the same system, if I am applying x of t, then without any doubt this input is going to be integrated. Right? Del of t convolved with u of t is going to be del of t itself. I'm sorry, u of t. Del of t convolved with u of t is nothing but u of t. Can you please tell me, for the same system that I have considered here, if I consider the input as u of t, and it is clear that your impulse response is nothing but u of t, impulse response is u of t, then what would be the answer? So what I can say is that u of t convolved with u of t, u of n convolved with u of n is dash. So this is something that we have to check whether it is r of n. Can I write u of n convolved with u of n? Any function you are convolved with u of n, the result is going to be what? As we have seen, that x of n convolved with u of n, it's going to be, the result is that k is equal to minus infinity to n x of k. Correct? X of n convolved with u of n, the result is nothing but k is equal to minus infinity to n x of k. So in the place of x of n, if you are having u of n, so it is summation k is equal to minus infinity to n, it is u of k. And we know what is u of k. U of k, we have just seen that u of k is 1 for k greater than or equal to 0, and it is equal to 0 for k less than 0. If you substitute k is equal to 0 to n, k is equal to 0 to n, k is equal to 0 to n, u of k. Tell me one thing, what happens if the value of n is less than 0? What if the value of the upper limit is less than 0? For the value of n less than 0, k is equal to minus infinity to n, u of k will be equal to 0. Will be equal to 0 because if any value of k, if it is less than 0, the upper limit itself is less than 0. So whatever summation you are talking is for the value of k less than 0 only. Then the value of u of k, summation u of k is going to be equal to 0. For the value of n greater than or equal to 0, then it can be divided into two parts. K is equal to minus infinity to the value of minus 1, u of k, and then you have k is equal to 0 to the value of n, u of k. So from minus infinity to minus 1, what is the value of u of k? It is 0, and here the u of k value is 1. So summation k is equal to 0 to n 1. Summation k is equal to 0 to n 1, which is equal to that of, what should be the answer here? Will it be 1? Will it be n or n plus 1? How many number of 1s are there? From k is equal to 0 to n. From k is equal to 0 to n, how many 1s are there? From k is equal to 0 to n, the number of 1s are n plus 1. Because from 1 to n you are having n samples, and at n equal to 0, k equal to 0, you are having 1 sample. So totally it is going to become n plus 1, right? N plus 1. So this is the result you are having. This is the result you are having. So what is the result I can write here? The result is nothing but 0 for n less than 0, and it is equal to 1, and it is equal to n plus 1 for the value of n greater than or equal to 0. So u of n convolved with u of n, can I write as n plus 1 multiplied by u of n? Can I write it as n plus 1 multiplied by u of n? Because u of n, what is u of n? U of n itself is nothing but 0 for n less than 0. If u of n becomes 0 for n less than 0, okay, so the total result is going to become 0. For n greater than or equal to 0, u of n value is 1, we know that. For n greater than or equal to 0, the value of u of n is 1. So the result is going to be n plus 1. Okay, so I can write it as a n plus 1 multiplied by u of n. N plus 1 multiplied by u of n. I can further write it as n into u of n plus u of n. N into u of n plus u of n. What is n into u of n? N into u of n is nothing but r of n. So the one small change that we are having is that the answer is not r of n, just like the way we think. The answer is not r of n, it is going to be r of n plus u of n. It will be r of n plus u of n. Right. So what we can say is that del of n, if you are doing the summation, k is equal to minus infinity to n, we will get u of n. And if you do again summation k is equal to minus infinity to n, you will not exactly get r of n, you will be getting r of n plus u of n. So this is nothing but something like the way we had del of t, u of t, r of t. So that means the value of the ramp will saturate to a step? No. It doesn't mean that, because you are getting r of n still. You are still getting r of n plus u of n. It only means that your r of n will be added with u of n. Your r of n is going to be added by u of n. Right. So I'll explain once again. See, the question is that u of n convolved with u of n, right? U of n convolved with u of n. So when you're doing u of n convolved with u of n, according to the formula, we can write it as k is equal to minus infinity to n x of k. So here in the place of x of n, you're having u of n. So I'm writing u of k. Okay, so this is what we are getting from the formula that we have. Any function is going to be convolved with a step function. It will be summed. It will be summed. So here I'm convolving with u of n, so it is going to be summed here. Okay, so what is u of k? U of k we know it is nothing but 1 for k greater than or equal to 0 and it is equal to 0 for k less than 0. Correct? So now, if my upper limit n, if the value itself is less than 0, if the upper limit n is value itself is less than 0, then the total summation is going to become 0. The total summation is going to become equal to 0. Yes or no? So therefore you are having a 0 here. If the value of n is greater than or equal to 0, if the value of n is greater than or equal to 0, then what is going to happen? Then the same summation will be divided into two parts. One part is from minus infinity to minus 1, where the value of u of k is equal to 0. K less than 0 means minus infinity to minus 1. The other part is, because the value of n is greater than or equal to 0, so I'm taking the part from 0 to n. I'm taking the part from 0 to n, where the value of u of k is going to be 1. So if you are summing 1, n plus 1 number of times, you are having total n plus 1 number of ones. So totally it's going to become n plus 1. So the result I'm writing here is that u of n convolved with u of n will be equal to n plus 1 for n greater than 0, n greater than or equal to 0, and it is going to be equal to 0 for the value of n less than 0. The same thing can be written as n plus 1 multiplied by u of n, because we know u of n itself will become 1 for n greater than or equal to 0 and u of n value is equal to 0 for n less than 0. So in a single step, if I want to write the result, I can write like this: n plus 1 multiplied by u of n. So I am taking u of n inside, it's n into u of n and u of n. N into u of n, again we have seen in the previous classes, I can write it as r of n. So r of n plus u of n. Okay, so basically what you are doing here is nothing but you are trying to sum the u of n. The result you are going to get is nothing but r of n plus u of n. So when you are trying to sum u of n, the result you are getting is r of n plus u of n. If you are trying to sum del of n, you will be getting u of n. We have already seen this, right? We have already seen this, that del of n convolved with u of n. Because any function when it is convolved with del of n, it will be the same function. Any function when it is convolved with del of n, it will be the same function. That is what we have learned, right? So by this logic, I can say that when del of n is going to be when del of n is going to be summed, the result is going to be u of n. But when u of m is summed, it's going to become r of n plus u of n. And this logic we already know, the relation that we are having between del of t, u of t and r of t. So what is the meaning of minus infinity to n? Just like the way we are having an integrator, in the same way we will be having a summer. Okay, your summer is not going to depend upon what you are applying here. Your summer is not going to depend upon, it's like a tool, right? It's like a tool for you. We know that u of n is starting from n equal to 0. But because u of n is starting from n equal to 0, I cannot change my representation of a summer. The representation of a summer is always like this only. The representation of an integrator is always like this. It is not going to change depending on your input. Okay, I'm sure I have understood your question clearly. So what you are asking is that why can't we take it from 0 to n? Why are we taking it from minus infinity to n? Okay, because from minus infinity to n is nothing but the formula for a summer. The formula for a summer is nothing but minus infinity to n. Just like the way the formula for integrator is from minus infinity to t. So your summer formula will not depend upon your input. Okay, the effect might happen that when you put u of n here, we know u of n starts from n equal to 0, so we will consider it. But because of that reason, we will not change the formula for the summer. Because summer is something which is common for u of n or any signal which starts from minus infinity. Okay, so I told you only one important formula. X of t convolved with u of t. X of t convolved with u of t is going to be integral minus infinity to t x of tau beta. This is important, and its discretized version x of n convolved with u of n is going to be summation k is equal to minus infinity to the value of n x of k. This is the very important formula that we have learned, and on the basis of this only we are able to comment on these particular results. This is the consequence of this particular formula. Okay, u of n convolved with u of n is nothing but n plus 1 multiplied by u of n. This comes because we have seen that when you solve this, you got the result as 0 for n less than 0. We got the result as 0 for n less than 0. For n greater than or equal to 0, we got the result as n plus 1. So the result of this u of n convolved with u of n is nothing but 0 for n less than 0 and it is equal to n plus 1 for n greater than 0. So when you are getting 0 for n less than 0 and you are getting n plus 1 for n greater than 0, I can write it as n plus 1 multiplied by u of n. Why? Because this u of n itself is 0 for n less than 0. So whatever result you are getting is valid. For n less than 0, u of n is 0. So the total result is becoming 0. The total result is becoming 0. For n greater than or equal to 0, u of n is 1. For n greater than or equal to 0, u of n is 1. So you are having n plus 1 as the result. So instead of writing in 2 lines, I can write in a single line if I am having a representation like this, n plus 1 multiplied by u of n.